What is indexing? Imagine you're reading your favorite book and you need to find a specific piece of information. You flip to the back of the book and start searching the index, which takes you straight to the page. The index of a book contains keywords organized in alphabetical order to help you find information faster than trying to scan through the entire book, which could take a very long time. From a technical perspective, indexing, or more specifically database indexing, works in a similar way. It's the process of enabling faster retrieval of data from a database. More specifically, it's a special data structure that allows a user or an application to quickly access the data it needs without having to check every single record. How does indexing work? The book analogy explains indexing at a high level, but to understand indexing at a deeper level, let's imagine a simple database full of numbers 1 through to 10 in random order. To search for a number such as 6, the most basic search would be to go through each record one by one until the number is found. If there are multiple occurrences, then the entire table needs to be checked, and this is called a full table scan and is generally very time-consuming or expensive in tech lingo. Enter indexing. When an index is created on a table, a separate mini-table is created where all the numbers are first ordered. Intuitively, this immediately speeds up the search because we need to search at most 6 numbers, as it needs to only scan up to that number in the sequence, 6 in this case. However, the simplest strategy to search for a number is one that kids often use when playing a guessing game. Say we had to guess a number between 1 and 10. Select the number halfway, 5, and determine if this is larger or smaller than the desired search number. If it's larger, then we know that the number is between 5 and 10. Pick another number halfway, such as 7, and if it's smaller, then we know that the answer is 6. This is essentially how the simplest database index works under the covers to retrieve data as quickly as possible. There are lots of different algorithms out there that are used, but fortunately, all of this is handled by the database under the covers, so we don't need to know the details. The outcome, though, is that when you're searching for someone's phone number from a database of 10 million users, you get the answer within milliseconds. What is a blockchain? A blockchain can be thought of as a very slow and inefficient database where data is stored in groups or blocks. For example, imagine an Excel spreadsheet with a list of 1,000 rows of data. We then create multiple Excel sheets and then link them together. This is basically what computer scientists call a linked list. If we now think of an Excel sheet of the same 1,000 rows as a block of data, and instead of linking them, we change the terminology to chaining them together, we then have a chain of blocks, or a blockchain. Another very important aspect of a blockchain is the fact that it is distributed. In other words, it is a network of databases around the world where computers or nodes maintain their own copy of the blockchain and interconnect with other nodes as well. Blockchains are also decentralized, meaning there is no central authority that controls the blockchain network. Decisions are made through global agreement or consensus by all the nodes participating on the network. The properties of being distributed and decentralized actually underpins the blockchain industry because a distributed network cannot be taken down by any one state, and a decentralized network cannot be overpowered by any one state either. What is blockchain indexing? Blockchain indexing is simply the process of trying to access data on the blockchain in a very fast and efficient manner. However, in addition to the standard database indexing techniques explained above, enter blockchain indexes. Blockchain indexes scan the blockchain for only the relevant data required by a decentralized application or dApp, and then stores this in a database. This makes retrieval of blockchain data orders of magnitudes faster because, firstly, only a subset of the blockchain data is processed, and secondly, traditional database indexing techniques are then applied. How does blockchain indexing work? In the early days, developers would query the blockchain directly using a technology called Remote Procedure Call, or RPC. This was slow and inefficient, so some developers hosted their blockchain nodes themselves, which was an improvement, but it still couldn't compete with the traditional database technologies. Some developers then extracted the entire dataset from the blockchain and stored it in a traditional database. Then, existing database indexing was applied to enable dApps to retrieve data faster. This was fine, but replicating the entire blockchain in a database is time-consuming and a waste of space, especially if a dApp only uses a subset of the data. Blockchain indexing works to improve the way blockchain data is accessed and utilized by allowing the user to define what type of data a dApp requires. The blockchain indexer then extracts this data quickly and efficiently and then stores it in a database as usual. As an example, the Ethereum blockchain contains a list of every crypto token and its associated transaction ever made. As of September 2023, this currently totals just under 21 billion transactions. To search for a particular transaction, or maybe your favorite Bored Ape NFT token, you would have to scan all these records, which would take a very long time. A blockchain indexer would go directly to all the Bored Ape NFT token transactions and save these transactions into a database. The database indexes this data, creating a separate subtable where all the transactions are ordered for the NFT, making searching much faster. Who uses blockchain indexing? With users demanding more feature-rich dApps, this in turn means processing more data. Therefore, dApp developers often require blockchain indexes to process only the data that they need to keep their dApps lightweight, fast, and responsive. Blockchain indexes can power a wide range of dApps, such as crypto wallets, blockchain analytic dashboards, or even blockchain-based search engines, answering questions such as what CryptoKitty has had the most kittens. It should be evident now why blockchain indexing is important. It's to allow the retrieval of this data quickly and efficiently in order to power dApps that are consuming the data itself. However, if we look at the growth of data over time, modern databases currently store petabytes of data. A petabyte is 1,000 terabytes, and if a standard laptop hard drive has 1 terabyte of storage, this would be the equivalent of 1,000 laptops. It has been estimated that X, formerly Twitter, generates 4.3 petabytes of data a year. Facebook, on the other hand, is estimated to generate 4 petabytes of data per day. Comparing this to the Bitcoin blockchain, as of 2023, the current size is just under 500 gigabytes, or half a terabyte. A full archive Ethereum node totals around 11 terabytes. So while these are not as big compared to X and Facebook, a blockchain is an append-only database. This means that information on the blockchain is stored forever and will continue to grow in size forever as well. This makes blockchain indexing even more important as the blockchain grows in size and popularity as more and more dApps are created using the blockchain. To make things more interesting, there are also lots of different types of blockchains. Bitcoin was the very first blockchain invented back in 2008, but since then, there are hundreds of other blockchains in existence. Avalanche, Base, Cosmos, Ethereum, Near, and Polkadot, just to name a few. This is where blockchain indexes really shine because they have the ability to grab data from all these blockchains and store them in a single database, and if designed correctly, in a unified way. This allows blockchain developers to create even more powerful dApps in an ever-growing and interconnected blockchain world.